Hello everybody, my name is Nikhil and you're watching me on Math Academy. So in today's video, we shall be actually discussing the origins of trigonometry. What is the purpose of trigonometry and how the whole concept of trigonometry evolved over time. It was just basically known that trigonometry is used to measure heights and distances. It is used to measure huge heights like the height of a tree, height of a mountain, height of a huge building. All these things are measured with trigonometry. But how did the first person who used the concept of trigonometry measure that particular height? That is what we will be discussing here, because that is extremely important in the sense that even today, if we are using one of the most complicated machines in order to measure the height of an object, still that machine also uses the basic mathematics that was developed in the time of Euclid around 2500 years ago. So in this video we shall be doing that, discussing about how the first person measured the height using trigonometry. So, for understanding the purpose of trigonometry, I'm going to take a tree, because a tree is a huge tree. It is not a small tree, it is an extremely huge tree. And this huge tree, which has a lot of leaves and stuff like that, yes, we have a leaf for all the trees and stuff like that. And of course, it has a bark, yes. So, this is my tree. And there is a person who is very small. It is not like the person is not small, but the tree is large. So and he is standing there, he or she, and he or she wants to measure the height of the tree, and they don't have any tape that actually has the length to measure the height of the tree, because the height of the tree is very huge. So what is it that we can do? So for that, they decided to use, they were actually working out a lot, what is it that we can do in order to measure the height, and they tried a lot of options, and but they were coming to a conclusion that we cannot actually measure the tree with the help of a tape. We'll have to find some technique that is going to help us rather than using a tape to measure it. So for that, a mathematician came in, and the mathematician said that why don't you use the concept of similar triangles? Okay, so he didn't understand how do I use this concept of similar triangles. Similar triangles is extremely easy to use, man. It is actually, we can actually use the concept of similar triangles to measure the height. Okay, so can you actually show me how it is done? That is the next thing. Can you actually show me how similar triangles is done? Alright, I'll show you. So for that, you need to understand the similar triangles first. Alright, fine. So, and I think before knowing the triangles, you need to understand a concept called as line of sight. Okay. Actually, so you can see this is the concept of line of sight. Now for understanding that in a better manner, I'll show you something for you. Alright, now you can see that I'm looking straight. Now you can see this is my line of sight. The way in which I'm holding my pencil is my line of sight. You can see this is parallel to the black color or the ground. This is my ground level. Alright, so this happens to be my ground level, and the line that I'm holding is actually like this, that is parallel to it, right? Now once I start to look upwards, now you can see there is an angle being developed, right, with my line of sight and my ground. So if I take another pen, say for instance I'm taking this remote for my example, both of them are actually like this now, and now once I look up, you can see that my line of sight is actually right now like this, and you can see an angle being developed here, right? You can see an angle being developed to the line of sight. So this angle is going to help me. I hope you are able to see it. You are able to see it, right? This angle is going to be the angle between the line of sight and the ground. Is that clear? So when I'm looking straight, you can see my line of sight is in par with the ground, and once I start to look up, this is going to be my line of sight, and this line of sight is going to be making an angle with the ground. Is that clear, everyone? I hope that logic is clear for everyone, right? And the next thing that the person there, okay, there is someone to help him out, right? So he said, like, what do? You just go and measure this distance also, how much far away that you are from the tree. So what he did was he just took a scale, he just took a tape, and he measured that this distance was around 500 meters. That means that he was 500 meters away from the tree, and he also measured the angle theta, and he found out that this angle was equal to 30 degrees. So you got the angle also. So two informations is something that they got. They got the information that they are looking up at a line of sight of 30 degree, and they are at a distance of 500 meter away from the triangle. So what the mathematician did was, just come here. Now let's draw a triangle. He said, like, I could have drawn the triangle earlier, but what I did was I just wanted some information. So what I did was I'm going to draw a triangle now. Yes, I'm taking this. I'm taking this. I am just drawing a line at a high line upwards, and I'm going to measure the angle here to be equal to 30 degree. I'm going to measure the angle to be 30 degree angle, and I'm going to construct a line here. I'm going to measure an angle 30 degree, and then I'm going to construct a line here, and the line will look something like this. Yes, this was my angle 30 degree. I'm sorry. Yes, this was my angle 30 degree, and he constructed a line, and he said that you can see the formation of something called as a right angle triangle happening here, right? You can see that if I actually erase these two lines, if I just make this point, I just identify this point, and what I can do is that I can actually delete these lengths, and I am able to see that you are having a right angle triangle forming here, right? I can see a right angle triangle forming here. Now what he did was, you have this distance to be 500 meters, right? So he just measured this distance. What is this distance? And he measured this distance and found it to be, that is, he did that use the help of a scale, and he found out that this distance was around 50 centimeter. That's it, just 50 centimeter, because it was drawn on a paper, and he did, it was, let me make it, so I don't want it to be 50, I'm making it smaller, so it was a 10 centimeter line, extremely small line. It was a small triangle that he made. So this was making an angle of 30 degree, and this length was 10 centimeter. What the next thing he did was, he made that an angle here, the angle was how much? This angle was 90 degree. 90 degree, and he asked me to imagine a triangle here. He asked me to imagine a triangle here. Okay, so he's just drawing a triangle, and he's asking me to imagine a triangle here, and that is a very interesting thing to do. He's asking me to imagine a triangle here. Let me actually try to imagine this triangle. Yes, this triangle is something like this, and he named this triangle, this is an imaginary triangle, there is no triangle drawn, and he called this triangle as ABC, and he also called this triangle as PQR. And he said that if this angle is 30 and this angle is 30, this angle is 90 and this angle is 90, that means that by angle similarity we can say that these two triangles are similar. Which two triangles? Triangle ABC and triangle PQR are similar triangles. And how did he say that? How did he come to that conclusion? Because he said that this angle 30 degree and this angle 90 degree are same in both the triangles, in triangle ABC and triangle PQR. So we can say that triangle ABC is similar to triangle PQR. So we have two similar triangles. From this he came to one more conclusion, that is AC divided by PR is equal to BC divided by QR. AC divided by PR is equal to BC divided by QR. Now that is a very interesting proposition, because from this he know that the length of AC happens to be 500 meter. So it was in meters, and he wanted this in 10 centimeter, right? So he converted that into centimeter. So if I'm converting this into centimeter, I have to multiply by 100 divided by 10. So that is going to be how much? This is going to be AC divided by PR. We got the value of AC to be 500 into 100 centimeters, and this was in 10 centimeters. Now what is the length of BC and QR? We know that the length of BC is completely unknown, because I don't have any methods to measure the height of a tree, so that remains unknown. But can you measure the length of QR here? Yes. Why can I measure the length of QR? Because you have the triangle in the paper with you. So what you do is that you will take a scale and you will measure the length of QR. What if the length of QR happens to be somewhere around, say I am saying that this length happens to be somewhere around 17 centimeter. He measured the angle to be somewhere around 17 centimeter. So that means that it was not a correct measure. He just measured it. Okay, he measured it to the scale, and he got that the measure was approximately 17 centimeter. And so here you can see that this length BC can be found out very directly by multiplying 500 into 100 into 17 divided by 10. Just a simple cross multiplication will yield you the result of BC. So from this what we can understand is that, actually it is very possible for us to actually measure these impossible heights. Say for example, height of a mountain. Say if you want to measure the height of Mount Everest, it is possible. If you want to measure the height of a huge building, it is possible. It is possible without actually making much of an effort. It is, of course it is an effort. It is not like it is not an effort, but we will be able to use the concept of mathematics, and we will be able to use this measurement. So but the idea is that we were able to do it because this angle was 90 degree, and this triangle was right angle triangle. If it was not a right angle triangle, we would not be able to make these two triangles to be similar very easily. Because this angle was 90 and this angle became equal, automatically we were able to use the AA, angle similarity. So for that, they understood that there is something very important regarding this right angle triangle, and this right angle triangle became the center of attention for measuring heights, because they didn't have any equipment at that point. They just had this number, a pen and paper. That is the only thing that they had, and a small tapes, right? So use this concept in order to measure this heights. And of course, it was during this time that Mr. Pythagoras came up with another theorem called as Pythagoras theorem. So when Pythagoras theorem came in, and of course the idea that right angle triangles can be used to measure heights, both of them together gave up to both of them together actually developed a branch of mathematics called as trigonometry. So the branch of mathematics trigonometry is the brainchild of who? The idea that height could be measured, or extremely large heights could be measured very easily using the concept of a right angle triangle. Also, in a right angle triangle, there is the sum of squares of two sides is equal to the square of the hypotenuse. So these two concepts coming together gave up to trigonometry, as I said again. So thank you for watching this. So that is the idea of trigonometry, and of course this leads to our, so this is not actually going to help you in any way for your examinations. I just said this so that it just incites you the idea, it gives you insights into how this trigonometry developed and what is the importance of trigonometry. Even today, even though we are actually using a lot of equipments to measure heights, but all these equipments are based on the calculations that was done centuries early. It was done actually, if you ask me, this was actually method in the time of Euclid. Euclid goes back around 2500 years. So that means that it has been on the ground for almost 2500 years, and even though we are using a lot of equipments, you might not see that, you might have a remote like this. You press at one button and you can see the height. There are kind of equipments, but these equipment, how do these equipments function? When you press a button, how is it that this is able to show the height? There should be some form of calculations going on inside, and that calculation is exactly the one that was measured 2500 years ago. The same method is being used. It is just that earlier it was done with the help of a hand, and a person had to sit and think. Right now you have already certain machines that do the work for you. So I really hope that you were able to understand the concept of how the first person used the concept of trigonometry in order to develop, or in order to measure the height of a tree. So this concept, I think, has been extremely helpful for you, and I hope it has been interesting for you. So if you feel that this video is useful and interesting, please take your time to subscribe to our YouTube channel and like the video, of course, and comment your opinions regarding this. And of course, if you would like to know more things about how in the origins of mathematics, please comment here. I shall try my level best in order to bring you all the origins of these things. So thank you everyone for watching this video. I'll be seeing you soon in another video with the next concept of trigonometry or any other concepts or whatsoever. Thank you. Keep tuned in. It is me, Nikhil, signing off from Math Academy, and I'll be seeing you in the next video. Goodbye.